Welcome to OnCore Live 2022. I'm your host, Robin Bell, and we are really glad that you're here with us today. This is our second product and technology webisode, and we've got an exciting program for you today. So get ready for the latest trends and information to help you better serve your customers and grow your business. On today's webcast, we're going to focus on product technology and innovations in the building and construction industry and the continually evolving EV battery segment. You're going to hear about some impressive advancements in both segments, which are creating new opportunities for pressure-sensitive adhesive technologies. The automotive industry, it continues to search for viable adhesive and tape solutions that meet the technology and safety requirements for electric vehicles and battery packs. And coming off of the battery show, we've got some new information and innovations to share with you. Avery Dennison is the R&D leader creating the PSA innovations that are driving the EV battery pack revolution. And joining us now to talk EV is Avery Dennison Performance Tapes' Luke Johnson. Hey, Luke, welcome to OnCore Live. Glad to have you with us.
Hi, Robin. Happy to be part of the show.
Yeah, good. So, could you begin by telling us a little bit about yourself and your role with Avery Dennison Performance Tapes?
Sure. I've been with Avery Dennison Performance Tapes for 7 years. I'm a senior R&D engineer, and my responsibilities include automotive, but also building, construction, and many other segments. And I'm usually responsible for researching, developing, trialing, and launching new concepts and products for performance tapes. Over the years, I've been intimately involved in the development and launch of several generations for EV battery portfolios, including this next generation flame tough rubber, which we're going to talk about.
Yeah, I'm excited to talk about that. Why don't we talk about EV batteries and the opportunities for tapes in the battery pack? Why are pressure-sensitive solutions important?
I think the number one reason that automotive OEMs turn to PSAs is for the speed of assembly and the potential for speed of assembly because they offer instant green strength. You're not waiting for a cure, and even more importantly, you're not waiting for a cure that could go wrong on expensive parts, which could lead to downtime or scrap. Our Avery Dennison solutions are backed by material science, and so they are specially formulated and designed for whatever materials are being used. And of course, they're there to help make battery packs safer, less flammable, more efficient for assembly, lighter, cheaper, and help solve common challenges like, dielectric protection and flame retardancy.
Yeah, a lot there to cover, and I'm excited to talk about all of this. So let's talk more about reducing flammability. What is it about the EV battery that makes flame retardant properties in specific PSAs so important and necessary?
Yeah, thermal runaway event is a very serious concern for automotive and battery manufacturers. There are tighter and tighter requirements being released every year. And as the pack voltage goes higher, you may have seen, well, I didn't see this problem before in batteries, but as that voltage for the pack goes higher, that concern for a short and a runaway event to happen is higher. The cell can overheat and get to temperatures greater than 600 degrees C, and then this heat will travel from cell to cell, and without any protection and with presence of oxygen will combust and set on fire. So obviously you can imagine this is a very heavy topic of focus for automotive OEMs and battery OEMs.
Yeah.
I really like this slide here because it kind of shows two different test methods that can be used to evaluate materials before they go in the pack. And many have probably heard these of UL94 VTM, which is for thin materials, and UL94V, which is more for thicker composite materials. The image that you see on the right, I really love. It shows what a traditional non-FR rated PET would look like when exposed to a flame for only a few seconds. And then you can see what flame tough looks like after exposed to flame. The flame will extinguish and not propagate and will help protect the battery pack, or at least not contribute to any further propagation.
Yeah, it's a pretty powerful image. So what about the materials that are used in battery packs? How does flame tough stick?
Well, what's unique about Avery Dennison is we've now launched 3 different classes of adhesives from our Flame Tough line, which includes an acrylic, silicone, and now newly a rubber. And this is really going to be needed depending on what materials or substrates you are bonding to, and maybe some of the conditions of the pack. You know, as I'll talk about later, the designs for battery packs and the modules are changing rapidly by the day for what materials are being used. And so having a wide portfolio to select from for flammability is important. And really want to hone in on the use of plastics in the battery pack. Plastics, especially low surface energy plastics like polypro, offer challenges for bonding for a lot of the acrylic tapes that are out there, which is why we launched our Flame Tough rubber line, being able to bond to these plastics, which are being used for lighter weight. They don't corrode from cathodic corrosion. They are obviously sometimes cheaper, and then they don't conduct electricity, which can offer a problem for batteries. So there's a lot of reasons that OEMs are moving to plastics and why rubber would be needed.
Yeah. Um, so you were mentioning dielectric properties. So what are dielectric properties, and also what new advancements do they offer?
Yes, so dielectric protection is another very common theme in battery pack design. You know, as your voltages go up, that it can arc more easily through the air to anything that is conductive. And so all surfaces that's metal or can conduct need to be protected. And surfaces can include the module for the batteries themselves, like a cylindrical cell, cooling plates. And we're actually launching another new tape for the portfolio, which is for our conformable dielectric, which offers the ability to conform around really tight radii and curvatures that you might see in a pack. A lot of customers out there are using PIs or PETs, which are great for flat surfaces, but the minute that they need to really bend around a corner to really bond well, they fall short, which is why this new conformable dielectric tape was launched.
Mm. Uh, so why don't we finish up with this? I know you just got back from the battery show. It was just a couple of weeks ago. Can you give us your impression of the show, and also what you found most beneficial at the show?
Yeah, it was a great show. It was very popular. It was packed wall to wall. That's a great image of my colleague Kyle talking there. One thing I saw a lot of with the different displays for pack designs is from the show from the year before is a lot more plastics were being used in the design of the battery pack, which means flame tough rubber or a rubber adhesive for those low surface energies are going to become more important.
Hmm. Yeah, so to your, which we're talking about with the plastics a moment ago, this is really interesting and exciting. And this is just incredible how fast the EV segment is moving and innovating. I'm curious to see where we end up, where we go. It was a pleasure having you with us today, Luke, and we appreciate your expertise and all this great information that you gave us. So for more information on the EV battery portfolio, visit tapes.averydennison.com/EV battery. Thanks, Luke. Appreciate it.
Thank you.
From all of us at OnCore Live, we want to thank you for joining us today.